For a 5 horsepower motor with a rated load amps of 16.7 amps, a number 12 American wire gauge conductor is appropriate. A 25 amp fuse should be used. For a 50 horsepower motor with a rated load amps of 143 amps, a number 2 American wire gauge conductor is required. A 200 amp fuse is suitable. Article 240.4d of the National Electrical Code applies to individual branch circuits supplying motors. This section mandates that the overcurrent protection, such as a fuse or circuit breaker, be rated no higher than the motor's full load current. However, there is an exception. If the motor is part of a group of motors operating together, Article 240.4e might permit a reduction in the required overcurrent protection. This is because the likelihood of all motors drawing their full load current simultaneously is reduced, and the code allows for diversity in the overcurrent protection sizing in such scenarios. When sizing conductors for motor circuits, several factors must be considered to ensure safe and reliable operation. Firstly, the conductor must be able to carry the motor's full load current continuously without overheating. The National Electrical Code provides tables, such as Table 310.15b16, that specify the ampacity of various conductor sizes based on their insulation type and installation conditions. Secondly, the conductor must be protected against overcurrents, such as short circuits and ground faults, which can damage the conductor and create a fire hazard. Overcurrent protection is typically provided by fuses or circuit breakers, which must be sized appropriately to protect the conductor without causing nuisance tripping during normal motor starting and operation. Thirdly, the conductor must be sized to minimize voltage drop, which can reduce motor performance and efficiency. Voltage drop is the reduction in voltage that occurs along the length of a conductor due to its resistance. The National Electrical Code recommends limiting voltage drop in motor circuits to no more than 5% of the supply voltage. When selecting fuses for motor circuits, there are two main types to consider: time delay fuses and instantaneous trip circuit breakers. Time delay fuses are designed to withstand the high inrush current that occurs when a motor starts without tripping. They provide overload and short circuit protection. Instantaneous trip circuit breakers, also known as motor circuit protectors, are designed to trip very quickly in response to short circuit. They provide short circuit protection only and must be used in conjunction with an overload relay to provide overload protection. The National Electrical Code provides guidelines for sizing fuses and circuit breakers for motor circuits in Article 430. These guidelines specify the maximum allowable fuse or circuit breaker rating based on the motor's full load current and the type of overcurrent protection used. It is important to note that these are general guidelines and may need to be adjusted based on the specific application. For example, if the motor is subject to frequent starts and stops or operates in a high ambient temperature, it may be necessary to increase the conductor size or fuse rating to compensate. Additionally, it is important to consult the motor manufacturer's instructions for specific recommendations on conductor and fuse sizing. These instructions may provide more detailed information based on the motor's design and operating characteristics. The general steps for determining the appropriate conductor and fuse sizes for a motor circuit are: firstly, determine the motor's full load current from the motor nameplate or the National Electrical Code tables. Secondly, select the conductor size based on the motor's full load current and the allowable ampacity of the conductor, considering the insulation type and installation conditions. Thirdly, select the fuse or circuit breaker rating based on the motor's full load current and the type of overcurrent protection used, following the guidelines in Article 430 of the National Electrical Code. Fourthly, verify that the voltage drop in the conductor does not exceed 5% of the supply voltage. If the voltage drop is too high, increase the conductor size. Fifthly, consult the motor manufacturer's instructions for any specific recommendations on conductor and fuse sizing. It is crucial to ensure that all electrical work is performed by qualified personnel who are familiar with the National Electrical Code and other applicable standards. Improperly sized conductors or fuses can create a fire hazard and damage equipment. Additionally, it is important to follow all safety precautions when working with electricity, such as wearing appropriate personal protective equipment and energizing circuits before working on them. The information presented here is based on general guidelines for standard operating conditions. It is always recommended to refer to the specific motor manufacturer's instructions or consult a qualified electrician for the most accurate sizing for your particular application. They can take into account any unique factors that may affect the conductor and fuse sizing, such as the motor's operating environment, load characteristics, and duty cycle. Remember that electrical codes and standards are constantly evolving, so it is important to stay up to date on the latest requirements to ensure compliance and safety. In summary, proper conductor and fuse sizing is essential for safe and reliable motor operation. By following the guidelines in the National Electrical Code and consulting with qualified professionals, one can ensure that motor circuits are properly protected against overcurrents and voltage drop. Always prioritize safety and adhere to the latest electrical codes and standards. For the 5 horsepower motor, the number 12 American wire gauge conductor and 25 amp fuse provide adequate protection and ampacity for the motor's rated load. The 50 horsepower motor requires a larger conductor and fuse due to its significantly higher full load current. The number 2 American wire gauge conductor and 200 amp fuse are suitable for this motor, ensuring that it can operate safely and efficiently. Article 240.4D's requirement that overcurrent protection not exceed the motor's full load current is a critical safety measure that helps prevent damage to the motor and conductors in the event of an overload or short circuit. Understanding the exceptions provided in Article 240.4E for group motor installations can allow for more efficient and cost-effective overcurrent protection in certain applications. However, it is important to carefully evaluate the specific conditions of the installation to ensure that the reduced overcurrent protection is still adequate to protect the motors and conductors. Always prioritize safety and consult with qualified professionals when making decisions about motor circuit protection. Remember that proper conductor and fuse sizing is not only important for safety but also for ensuring the long-term reliability and efficiency of motor-operated equipment. By following the guidelines in the National Electrical Code and considering the specific requirements of the application, electrical professionals can help ensure that motor circuits are properly designed and installed. This can lead to improved motor performance, reduced downtime, and increased safety for personnel and equipment.